In version 16.50, PLS-CADD now has the ability to evaluate the space potential and electric and magnetic fields as a cross-section for each structure. The space potential plot assists in the placement of ADSS cable attachments on structures to ensure the cable does not get damaged from the large electric potential from the current carrying wires, while the electric and magnetic field calculations can be used to evaluate the field levels around climbing spaces to ensure safety limits. In this video, we will demonstrate the inputs needed to use the feature and what output can be gotten from it. To begin, let's take a look at the example WPL line that ships with the software. This line comes already set up with several of the input requirements needed. The first requirement is that there needs to be a tin ground surface model created that encompasses the structures you wish to use this feature on. The second requirement is that you must have the circuit and phase labels defined and assigned to your wires. For more information on how to define electrical circuits and phasing, check out the link to our other YouTube video in the description below. These are the primary requirements needed to use this feature. However, if you wish to use this feature on dead-end structures, you must also model the jumpers to achieve accurate results at the cross-section points of the structure. Let's take a look at a tangent structure first. So I'll activate the 3D view and go to structure 110. Next, we activate the feature by going to Sections, Electric, Structure Space Potential Calculator. On the left-hand side, you get to select a range of structures, so I'll do just one structure and select number 110. On the right, you have the calculation settings here. The max wire distance determines if a wire will contribute EMF forces to the location analyzed based on its distance. So wires outside this distance threshold will not contribute to the analysis. The max segment size determines how often to break wires up into smaller separate pieces to determine each piece's individual contribution to the results. The point interval setting determines how fine of resolution to perform calculations on. Entering a smaller number will give smoother contour lines at the expense of analysis time. The default values are recommended for most scenarios, and alternating these values could increase the analysis time needed. The overvoltage setting here allows you to input a percentage of overvoltage. Typical values may be along the lines of 5 to 10%. The checkbox here to include structure members will take into account elements modeled in PLS-POLE or tower as being grounded objects. PLS-CADD does this by assuming each structural element in the model is a metallic cylinder. Here you can enter your field limits, which will show any contour lines above these thresholds in red, and then other colors as the fields weaken. When you click the Calculate button, you will see a text report with graphical cross-section views showing one of the space potential, one of the electric field, and another for the magnetic field. These options here are for allowing markers to be drawn in the 3D view of PLS-CADD. And to avoid confusion, you can only draw markers for one of the three options, but the text report will show you all three. So when we go to run the analysis, we see this table here. We need to enter the electrical current per phase. So we will enter 1000 amps for both circuits, for example. The shield wire and ground wires, we will leave those empty and click OK. It takes just a moment to calculate the wire positions and the charge densities on all of the individual wire pieces. This video isn't sped up in any way, so you can see how long a typical analysis takes for a single structure using the default settings. After the analysis completes, you can view the report, and it shows you all of the input settings used, and then you see the three graphical outputs for the space potential, the electric field, and the magnetic field. And you can see how, because I selected the option to include structure members, the field lines are shaped around the structures. Here's the same structure, but with the structure members feature disabled for comparison. If we close the report, we can then see in the 3D view that there's markers drawn at the cross-section of the structure showing the space potential results because that was the option we chose. If you zoom in, you may notice that some of the smaller contour lines can get a little jagged. Well, if you rerun the report, you can drop the point interval down to a smaller value, like 0.33 feet, and it will take a little longer to run, but the end results will show smoother lines for the smaller contours. Let's now run the feature again, but this time for a dead-end structure, and we'll choose a unique transposition structure like number 92. This time let's choose the option to draw the magnetic field lines in the 3D view and click Calculate. And again, you have to enter the current, so we'll enter the same 1000 amps for both the ahead span wires and back span, and then click OK. We'll let it take a moment to run. And now we look at the report again to see the results, and let's focus on the magnetic field results. Then if we close the report, we can see how in the 3D view the markers shown at the structure's cross-section are for the magnetic field and look the same as what we saw in the report. And since these are markers, we can clear them out easily at any time by pressing the F5 key. We hope that you find this feature helpful in your future ADSS and EMF related projects. Thank you for watching. If you'd like more information about our software, please see our website at www.powerlinesystems.com or contact us at info@powerline.com. To receive a quote for purchase or renewal of your license, please contact sales@powerline.com, and for any technical inquiries, please contact support@powerline.com. Thank you for watching and your interest in our software, the industry standard in overhead line design.